Okay, I haven't logged the meeting now. Let's see if people will be disciplined, will be a discipline. Now, exponential and logarithmic functions, laws of logarithm. Laws of logarithm, expanding and combining logarithmic expression, change of base. Log of logarithms. Now, this is very important, VVIP. You need to know, you'll use them in calculus, you use them in engineering maths, you'll use them. Now they say, since logarithmic are exponents, the laws of exponents give rise to the laws of logarithm. What does it mean? When you are multiplying two bases, when you are multiplying exponents of the same base, what do you do to the exponent? Sorry, my apologies, my apologies. My apologies. Thank you very much. Can you now see the screen? Hello? Guys, can you see the screen now?
Can.
Yes, ma'am.
Yes, ma'am.
So they're saying that remember when we our exponential laws, they're saying that the logarithms are exponents. So the laws of exponents give rise to the laws of logarithm. Remember when you were multiplying same bases, what did you do to exponent? You added the exponent, isn't it? So here it applies that if you're multiplying A and B, base A, then you add the. Do you remember when you were dividing as exponents of the same base, you were subtracting? That rule also similar to that when you are dividing this A over B with base A, this is that. And therefore, if you have log of A to the power of C base A, you can always take the C outside. So those are the laws of logarithm. Now they say evaluate the following expression. Guys, how do we evaluate the following expression using the laws of logarithm? These laws here. How do we do that? So we know that A is equals to, we see that this base and this base is the same. So this can be the same. So log base 4. But if we are adding this, meaning that we have this over here. We have this over here, right? Now, since we have this over there, we can reverse it and just multiply the A and the B. That's what that law is saying. So meaning that we can say 2 times 32. And we know 2 times 32 is what? 64. So log of 64 base 4. What's the answer there, guys? What's the answer?
3.
Not using a calculator. How do you find it? How do you find to be 3? Because you said what? Do you remember the log rule? Yes?
The expression is simplified to log 64, and then I used 4 to the power of 3.
Thank you. Remember the law that says if you have log of A to the power of x base A, then this is just equals to x, meaning that you can simplify the 64 to this will be equal to log of 4 to the power of 3. So this would just be equals to 3. Are we all together there, guys? Now let's look at B. B, there's a minus there, and we know that the minus means division. Please mute. So meaning that we'll have A over B. So this will be log of base 2 of 80 divided by 5. And what is 80 divided by 5, guys?
16.
16. And we can simplify 16 as what? 2 to the power of what?
4.
Thank you, because there's a 2 here. So if we have a 2 here to the power of 4, then it will be easier for us. Right? Now this over here, how can I rewrite this? How can I rewrite that? meaning that this is the fourth one. It says that if I have a constant times the log of a base small a, therefore this can be written as log of base a to the power of c. So meaning that this can be the power to this side over here. And this will help you in your assignment as well. So then this will be log of what? Of a to the power of -1 over 3. And we know what is the base of this log, guys. What is the base of this log based on what we have learned in the last section? What is the base of this log? Thank you. So this is log of base 10, which is the common log, right? Almost said natural log. So this, you can write it as 2 to the power of 3. So then minus 1 over 3 equals to log of 10, 2 to the power, just a half. And because you can't find a value such that when you power it, it gives you half, you can then, in this case, you will have to use a calculator. But because in this module, we're not using calculators, I will not give you number C in the exam or even in the assignment. How it all together, guys?
I'm sorry, ma'am. I just want to ask something.
Yes.
When you're doing this calculations on the exam, aren't you supposed to use the calculator, or we're still gonna stick to
No.
the rule that we're not supposed to use a calculator?
Yes. Remember, if you use a calculator in the exam, you think you'd get disqualified.
Sure.
Yeah. Some previous students, they got disqualified because they were seen using calculators. So that's
Even
what
for
I'm
this
saying,
kind
that
of section.
every section, there's trick in the next section. You're not using calculators in the next section.
Okay, ma'am.
You'll get used to it, guys. Practice, even now, practice your assignment without using calculators. You have 30 days, over 30 days for every assignment. So practice without using calculators. I will show, that's why I'm saying that I will show you how, but practice without using calculators. As I said, the last one will need a calculator, so we won't use a calculator. Is there a question?
Yes, ma'am, I have a question.
Yes.
Oh, so what happens if the logs are not the same? Like in A, it's log 4, log 4. What happens if the logs have different numbers?
If the logs have different bases, that's what you're saying.
If they have different bases. Yes.
Remember, even in exponential laws, remember when you had something like this, 5 to the power of x times 2 to the power of x times 2 to the power of 2x over maybe 6 to the power of x. You only added the ones with the same bases. So this was the same as just 5 to the power of x times 2 to the power of what? 3x. And you left everything else the way it is. You didn't do anything to it. So meaning that if they say log of a base 2 plus log of b base 3 is equal to log of a base 2 plus log of b base 3. So you can't use any property there. And this is also your chapter 1, remember. So it will be in the exam. The exponential laws. So there's the logarithmic laws as well as the exponential laws only applies when the bases are the same. They'll always say, when you're multiplying, bases are the same, add the exponent. Bases are the same, subtract. Bases are the same, you do that. So the bases have to be the same for you to use the laws above. Now they say expanding and combining logarithmic expression. I think this is the first question, if I'm not mistaken, in your assignment, right? Now they say the law of logarithm allows us to write the logarithm of a product or a quotient as the sum or difference of logarithm. This process, called expanding a logarithmic expression, is illustrated in the next example, right? So they say use the laws of logarithm to expand each expression. So what they're saying is they say use this. this to come here. Use this to come here and use this to come there. So you're going to use all these laws. So let's use them. This is your question 1 in the assignment. So the first one, it will be equals to what? A will be equals to log of 6x base 2 will be equals to what? Because you are multiplying, so you're adding them. So this will be log of 2, 6 plus log of 2x. Do you see that? Did I lose anyone? Guys?
We did see
Oh,
me.
man.
Okay. Now, B, we have log of x to the power of 3, y to the power of 6. This will be equals to 5. I mean, what am I saying? Not 5. Base 5. So this will be equals to what? Hello?
Log base 5
So
x to
log
the
base
power of
5.
3
Yes.
plus
Plus
log
log
base 5
5.
y to the power of 6. And
Yes.
then,
Am I done?
no,
Yeah.
you bring the exponents to the front.
Danko. Danko. You bring the exponents to the front, which is this one over here. This will help you when it comes to differentiation and integration as well. So then this is equals to, oh yeah, I'm getting a lot of disturbance. I think I didn't lock the class, but it's fine. Ooh, the pen is no longer writing. You see why we lock the class, guys? Ah, and then slide says me, I'm not moving anymore. So this is 3 log of x base 5. And this is plus 6 log of x base 5. Are we happy there? So meaning that C will be equals to, can you give me C? AB over root of 3C. Let's do C. Guys, let's do C. C looks similar to what we have in the assignment. I think we have log in the assignment.
We use law to expand.
Okay. So we use law 2 to expand. How are we going to expand then? How are we going to expand? Guys,
In
ln of
AB in brackets
AB, yes,
minus, cube root C.
cube root. Yes, are we done?
No,
Mm-hmm.
3 root C.
and then you expand you say in A plus in B.
Are
And
we
then
done?
minus in cube root C.
You're not
And
done.
then equals to 1/3 in C.
Well done. So can I get that 4 marks in the assignment as well in the exam? Whatever marks it is in the exam. Can I please get it? All of it.
Is
Yes.
Thank you. Okay, let's see. Alrighty. That's why we did exactly. We did exactly. Now they say the laws of logarithm also allows us to reverse the process, meaning that we're moving from here, going back there. Question 2 of assignment 3. So they say the law of the process of expanding that was done in example 2. So that is we can write sums and difference of logarithms as single logarithm. This process called combining logarithm expression is illustrated in the next example. So they say use the laws of logarithms to combine each expression into a single logarithm. Part of assignment 3 as well. So what do we do? Yeah. Let's talk. Asikulum. So what do we do here? A, where do we start? Can we have a
use log
different
L.
person? Can we use a different person, guys? Because I don't want to have hope and say only one person will pass very well the exam. No, I want everyone to pass. All of us. All of us. It's nice to have that feeling.
So it will be 3 log x plus half.
Okay, so 3 log x plus 1 over 2 log of x plus 1 will be equals to what?
Right. Equal to log x to the power of 3
X to the power of 3
plus log
plus
x
log
plus 1 to the power of half.
x plus 1 to the power of half. Then
Log to the power of half.
log
Wait. So it's, yeah, log into x cubed, another bracket, x plus 1 to the power half.
like this.
Am I right so far?
Are you done?
Yes, correct. No. Then it will be
Then?
log x to the power of 3. The square root of x plus half. X plus 1, sorry.
Are we all happy? Guys, are we all happy now?
Yes, ma'am.
So I can get those 2 questions in the exam. Thank you. Let's look at B. So I have 3 ln of s plus 1 over 2t minus 4 ln of t squared plus 1. Please help me. Help me. There's ln of t here.
Okay, so it's ln s to the power of 3
Okay, let's do that.
ln t to the power of half
Yes.
minus ln into t to the power of 2 plus 1 all to the power of 4.
All righty. So this is equals to
Ln brackets s to the power of 3 t to the power of half minus ln t to the power of 2 plus 1 all to the power of 4.
okay. Let's take this up here. Yes.
Okay, so it's ln s to the power of 3 square root of t minus ln t to the power of 2 plus 1 all to the power of 4.
Okay. Then
Will equal to ln s to the power of 3 square root of t over t to the power of 2 plus 1 to the power of 4.
plus 1 to the power of 4.
Yeah.
Done. Well done. I know you guys are tired. I'm also tired, guys. Don't worry. Let's see. And yes, we are right. We are right. So they say logarithmic functions are used to model a variety of situations involving human behavior. Now listen to this. One such behavior is how quickly we forget things we have learned. For example, if you learned algebra at certain performance level, say that 90% on the test, and then don't use algebra for a while, how much would you retain after a week, a month, or a year? Now remember that your exam is after a month. So meaning that if you don't practice, how much are you going to be okay during the exam? So this person, Hamen, ambiguous, I think, if the spelling is right, studied this phenomena and formulated the law described in the next example. They say if a task is learned at the performance P0, meaning initially you got 90%, then after time interval T, the performance level P, meaning after 6 months or 4 months that you guys will be writing in the next 4 months, P satisfies log of P is equal to log of P0 minus C log of T plus 1, where C is a constant that depends on the type of task and T is measured in months. Now they say solve for P. What is P? Hello? Solve for P. How are we going to solve for P?
Performance level after 6 months.
Yes. So basically you are studying now, isn't it? Right?
Yes.
And then you write your assignment. You get 100 in your assignment. If you don't continuously practice what you have learned in the previous chapters, in the previous assignment, are you going to get 90 in the exam as well?
No.
No. Chances are, if you don't use them, that's what this theorem says. For example, if you learn algebra at a certain performance level and then do not use it for a while, how much would you retain after weeks or months or year? Same applies. If you took answers from someone or bought answers and you got 100, what will be your performance level in the exam?
0.
All right. So this question is asking you to solve for P. How do we solve for P in this case? Let me take a screenshot. How do we solve for P? Let's think, guys. And what problems will be there from chapter 1 up to the chapter at the end? It has to be 1 or 2 or 3 word problems in the exam. How do we solve for P?
We try and isolate it.
Okay. How do we isolate it? That's a good start. How do we isolate it? So we have A log of P, which is log of P0 minus C log of T plus 1. So how do we solve for P?
Mm.
Divide by log.
Divide by log. Divide by log.
Ma'am, can we first use the second law, to simplify the second part of the equation before dividing by log?
Okay, so what do you mean? Tell me. So you're saying I should do what?
Like on the right hand side, right? The log PO divided by log T plus 1 to the power of
Divide
C.
by log.
Or divide by T plus 1 to the power of C.
Done. So meaning that now we have log of P is equals to log of P0 over 1 plus, C plus 1 to the power of C. That's what we have now. So then what do we do?
Then we can start dividing by logs. And
If you say divide by log, I'll pinch you.
Can
Pull
we
it
not
zip.
use base 10 to apply it on both sides?
Well done. Okay, you're saying put base 10. So if you put base 10, this is already base 10. So even if
Okay,
we
so
put
Bases
base
are the
10 like
same.
this,
it'll
it's
be 10,
basically the same.
10 log P to the power, yeah.
I
Oh,
think
no.
we can drop the logs because they're the same.
You don't just drop the logs.
What's that law? I don't know the law, but I know you
You will
drop the law.
faint. You will faint. Someone said something in the previous class. Can that someone come back? I told you that your answer was wrong there. It's right here. Come back. What law can give us? Deny. So what law can give us P? Isn't that here we want P only? And here we don't drop them, guys. You don't just drop. What law?
Log A
Please.
is log B equals log A over.
No, baby. No, don't lie. What law? You guys just learned the laws last time.
Ma'am,
Yes.
isn't the P gonna for the logs for us to get rid of the logs, the P is gonna push the PO divided by the T plus 1 squared.
But how do you get rid of the log, guys? You can't just get rid of the log. This is
You
minutes. You
divide.
don't get rid.
But
Ma'am,
ma'am,
this
why
is
do you
already
say you
proven.
can't divide?
You can't divide. So if you divide, you're going to do what? It's like
Ma'am, can we not write it as 10 to the power of log P?
Yes, you can. You can write it like that. Why are you writing it like that?
Because the explanation base 10 is applied on both sides to remove the logarithms.
Well done. There's a law that says if I have A, we did it so many times. If I have A log of A to the X, this is just X. That's the law. It's law number 49. This one, number 4. Do you remember that? Or you forgot it? Guys?
Ma'am, I just joined the class.
Okay, those who were here, do you remember it?
Yes, ma'am. But then in this case, what is A? What is our A?
Yes, ma'am.
Our A is the A, that base here. That law says that if I have a log of base A, ne? And I take this and I power it like this. This is A again. then it means it's because this a to the power of log base a is the same. Then the answer is just x. That's what that law said.
Yes.
Do you see that?
Yes.
So meaning that because here you knew it's a natural log, you were not even supposed to write this part, but it's fine. You knew it's a natural log. You know that log of p is actually log base p. It's a common log. Why am I saying natural log? It's a common log, right? So meaning that, remember in maths, they said what you do on your left, you do on your right. They didn't say they didn't say exactly what to do. Grade 3, they said what you do on your left, you do on your right. It means it's right in maths. Whatever you do, if you do it on the left, it must be done on the right, then it's right in maths. They didn't specifically, they said only for functions, what you do on the left, you do on the right. They just said what you do on your left, you do on the right. Meaning that if you have 2 to the power of 2 to the power of 2, and they tell you it's equals to okay, let me not say 2 to the power of a, and they tell you it's the same as 2 to the power of b, right? If you decide that you will multiply by 100 this side and multiply by 100 that side, this statement will be true. John this side times 2 to the power of a, and put John this side as well times 2 to the power of b. The answer will be what? Will be true, because they say what you do on your left, you do it on the right, then that's maths. So meaning that because I know of that particular law, that if I have a and then I have log of base a x, then because this and this are the same, that's the answer. So meaning that I can do that, and I can say 10 to the power of log of 10, okay, log of p. Let's get used to not putting, let's get used to that if we don't have a base, then we know that it's a common log. This, then you say 10 to the power of log of p0 over t plus 1 c. Then you are dropping the log. You're not dropping the log, you are applying the law. Since you're applying that law, so meaning that this and this are the same. So this 10 and that 10 somewhere they are the same. So you remain with p. So this is equals this and that 10 there is the same. You remain with this. So it's p0 over t plus 1c. Are we all together?
So, ma'am, you want to see that, what do you call that step where you, like, if I just, because remember I told you I know you just drop the log. If I just drop the log, will I lose that mark?
For me, I want you to know why you are doing it, because you didn't know why you were doing it. You have seen it's been dropped somewhere. Remember, maths is continuous. At some point, you'll use it, and then you drop when you're not supposed to drop. What if I had +5 here?
I was going to transpose it.
To where? Because even if you transpose it to this side, it will still be -5. And you come and drop the logs, and then you'll end up having p is equals to p0 over t plus 1 to the power of c plus 5, because you are just dropping the logs.
Mm.
Do you see that? But if you know that everything to the right and to the left should be to the power of 10, what's this? Should be 10 to the power of whatever it is, then you'll know that this will be p, this will be p0 over t plus 1 to the power of c plus 10 to the power of 5, because you applied the rule. You didn't just drop the log. I'm saying that because you need to learn why you're doing the next step. Are we all together now? Are we all on the same page? On the same
Yes,
page.
ma'am.
Thank you. In maths, if you don't know how to, because maths is continuous. That's why you're working grade 10. 11 is covered in grade 12 final past paper, because maths is continuous. So now they say if you score a history test 90, what score would you expect to get on a similar test after 2 months? So they're saying that initially you had 90. I'll do this together. Initially you had 90. So P will be equals to 90 over T after 2 months. So it will be 2 plus 1, where C is 0,2. We'll find the answer there. After a year, how many months? Because T was measured in months. T is measured in months. So after a year, it will be P is equals to 90 over 12 plus 1 to the power of 0,3. So that is the expression. In the exam, I can ask you for the expression and not the final answer. So let's see what will be the final answers. So they are saying that, okay, so we first combine the right-hand side, which is that, as we said, but we do not, you see, someone will think they just drop the logs here. You don't just drop the logs. You apply the law. And this is true because, can you see what I'm seeing, guys? Can you see what I'm seeing here?
Yes, ma'am.
Why are we allowed to
Yes,
drop
ma'am, we
the
can
logs?
see.
What am I seeing? And I'm sure you're saying yes, but definitely it's not what I'm thinking.
The log is 1 to 1.
Minus is a division.
1 to 1.
A log is 1 to 1.
Yes.
And if we know 1 to 1, we know the property of the inverse function. If we have y is equals to a to the power of x, we know the inverse of that is equals to log of what? Let's call this f of x, the property inverse function.
X
This
log
is how
of
I want
A.
you. Yes. Do you see that? Now we know that according to the property inverse function, what is the answer here? What is the answer here? If I compose f and inverse, what do I get? We did
X
do
log
that in the
A
previous.
to the power of Y.
Yes. So we get x here according to the property inverse function. And then if we put the other way around as well, we do get what? We do get x according to the property inverse function. And us saying a to the power of log of what? Log of a base x. We are using the property inverse function. That's why we're getting the answer to be x. Because of 1 to 1. Nice one. Yeah, maths is nice there. Okay.
Ma'am,
Are we all together, guys? Or
assignment.
I was the only one in the mood? Huh?
Is this in assignment? Because I was sitting with it today and this inverse f minus 1 x is there somewhere.
Why are you giving away answers now? Huh?
Let
Why
me
are you
just
giving away answers?
no, I mean this inverse function is there.
The property inverse function, we even did it in chapter 2. It's there. It's there. I'm giving you the basics so that you can be able to go and do your assignment. Once you're able to do your assignment and then you encounter a problem, you come back to me with your problems. Then we discuss them. You see? So me, I'm giving you the basics.
The inverse
Okay,
one
we don't
was a bit difficult because it is composition.
Yes.
But
And the
eventually
property,
you get it.
yes, because you are using this one, these rules, the one-to-one function, the property inverse function. That's how I want you guys to think. Don't practice maths as if you are practicing for grade 12 and go and do a lot of past papers. Because I'm not going to ask you. Question 1 won't be find x. Question 2, use quadratic, simultaneous, patterns and sequence. It won't be like a past paper that you have seen. You just come in and you see I ask you, What is the average gradient? A lot of people didn't expect that question in the supplementary, which is a very easy question, you see. So let us move on. Now here's P. Now they're telling you see what the theorem is saying, guys. Initially you got 90% because you studied very hard. After a month, you come back. Now you have 72% because you were not practicing maths. That's why it's continuous. After 12 months, you get 54%. Imagine last year you got 90%. In the same exam, you get 54%. Not even the same exam. Same work, you get 54%. So this means that if you're not continuously practicing, or if you're not continuously doing your particular task, in this case, it's practicing maths, then chances are your marks will go low, 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 low.
But they use the calculator there.
Yes, that's what I'm saying. Me, I will not ask you for the answer. I'll ask you and see if you can do the expression in the exam. Yes. But here I'm just now. You expect the score after 2 months and after 1 year. And 54 respectively. Guys, let me mute, please. Hello. Okay, it's not back. Thank you. Change of base formula. Change of base is also important. Someone said I made an error in let me not give away the answer. In the assignment somewhere. I went and I noticed it's called the change of base formula that needs to be used. And I redid the question, So if you didn't use the change of base, you'll see errors, my friend. For some purpose, we find it useful to change from logarithm in one base to another logarithm, to logarithm in another base. Suppose we are given log of ax and we want to find the log of x base b. So they say we are given, this is what we are given. Suppose we are given log of x base a and we want to find log of x base b. So let y is equals to log base bx, right? Now they say that we can write it in exponential form. Do you see that? So we move from here and we wrote it in exponential form and we know it's like this in exponential form. Now, because we want to change from, we are given this and want to change to find this, therefore, we can take logs of a both sides. Remember what we said in maths. What you do on your left, you do it on the right. Then it's true. So then you take this y, put it here. So then you have y is equals to log of g base a is equals to log of x base b. Then you have changed your base. This is called the change of base formula. So meaning that the new log will be equals to y is equals to log of x base a and log of b base a. Did that make sense, guys? And we call this the change of base formula. So they're saying that log of x base b can be written as log of x base a over log of b base a. So we have changed our base basically. Why is it quiet? Why should I be worried?
No, we are trying to figure it out. We're trying to see if we understand.
Okay. Please see, I'm going. Yes, I'm listening. Please see, I need 2 seconds.
Yeah, ma. I will locate it. And never tun tung tung. Nega se will also repeat. Like nenga se won't repeat.
Okay.
I sure will.
Okay. We are here. Someone is complaining that they can't enter the class. Or maybe the picture is from another story.
Na re tseba bolela ka nna.
Go qoqela taba tsa hae. Tima mic. And
Okay.
Lileka. Switch off your mic.
Guys, one day you will tell us things that you're not supposed to tell us, eh? Hey. Okay, so this proves the following formula. This is called the change of base formula. It can be used. It's going to be used somewhere. I won't tell you where, but I saw it, and I was happy when I saw it. So in particular, if we put x is equals to a, then we know that log of a base a is 1. And now this formula becomes this. So it changes, becomes something like this. Are we still together, guys?
Yes.
Now use the change of base formula and a common or natural log to evaluate each logarithm. So we're not going to round off to decimal places. We're just going to use the change of base formula by using the common log and the natural log. Let's start with A. And we'll only show the expressions. Can we do that, please? So let's take
we
that.
log 8, 5 is equal
So
to
we have log 8, 5 will be equals to
log 10, 5
log 10, 5
over
over
log 10, 8.
10, 8. Do we agree, yes or no? I don't want us to write the base 10, guys, because remember, we need to
Yes,
get
we
used
agree.
to the fact that this is a common log. So it's written
Yes.
as log 5 and log 8. So when we use the natural log, it will be what? The natural log will be what?
Log 9, 20.
No. For here, we still at A.
Okay. So it'll be log 10, 5. I mean,
10,
sorry,
5. So we log
5 and then log 8.
log 5, log 8.
And then log 8.
The natural log, we're using the natural log, the base, change of base formula, and the natural logarithm. Now, what is the base of a natural log?
10.
10.
Natural log. Natural log.
It's
Thank
E.
you.
Hmm?
Base E.
Oh.
So it'll be log base E. What here? What am I writing here?
10. Oh,
This is B.
5.
So it'll be 5
Mm,
over log E.
8.
8.
And we know that this natural log is ln of 5 over ln of 8. That's the change of base. So B will be equals to log of, if we're going to use the common log, we know the common log is base what?
10.
10. So this will be log of 20 over log of 9. Thank you. And this one will be natural log.
Log
So this
E
will be
20.
log of E 20 over log of E,
E 9.
which is ln
Ln
of
20 over
Len 9.
E 9.
Danko. So that's how you use the change of log. Now, in the questions in the assignment, at some point you have to use the change of logs.
Yes, the last question.
Aibo, we said that we're not giving away answers, guys.
Sorry.
You can't be giving away answers on where this information that you are given now. You'll only give away answers when you write the assignment in group. What do you call it? The memorandum.
Are we doing the memorandum with this one as well?
Yes, all of them.
Yo.
I want you guys to discuss all of them. Isn't that we agreed on the price? I didn't tell you what the price is, but we agreed that I'll give you a price collectively.
What price?
Collectively.
A
All of it will
prize.
benefit everyone.
Yeah, and
Price for 3,000 people.
for the ones who did the memo.
Okay. For all assignments.
You have to do the memos for all the assignments. There are 2 rewards. One I will not mention now. The other one I will also not mention now. But I'll tell you the rewards later on.
Oh, okay.
Hi, ma'am.
One is money.
The second one is iPhone.
Yo, guys, I'm not rich, me.
Ma'am, can I ask you something?
Yes.
Ma'am, I just want to know, is the assignment recorded?
The assignment?
The class, I mean to say the class, is it recorded? Some of us, we are at work and we cannot attend the full class.
I hope this one is recorded. Yes, this one. I almost fainted. It's recorded.
Okay, ma'am. Thank you so much.
No problem. Sharp. I almost fainted. Sure. How can you ask me a question like this during class? So this part is where you will end in the assignment. I mean, in the assignment as well as in the exam. This part here. Well, I will not ask you for 1,55. How? And then we are done with the class just like that. Yeah, that was quick news. Okay. I don't know. Of the recording. Any question regarding the work first? Okay, no work, then I stop the recording. Then you have 9 minutes to ask me questions